Okay, so let's talk about so-called X-shaped radio galaxies. These are active galaxies that actually have two pairs of jets. So I can't seem to get my laser. So on the upper right is an actual image of this kind of object. And what you see is, well, unfortunately, I can't get my laser pointer, so I can't point to this, but what looks like a jet pointing away from the red object, that's the center of this active galaxy, and sort of pointing up and slightly leftward and downward and slightly to the right is one set of jets. And then you see another that starting from the red point in the middle looks like it's pointing downward but mostly leftward, and then slightly upward and mostly rightward. And for many of these objects, it looks like there is a time difference between these two sets of jets. One was formed before the other. And the other observational features of these X-shaped radio galaxies is that these the powers of these jets seems to not be among the largest. So these are not very powerful FR1s or FR2s. So that's something that we need to explain. And there's also an observational fact, which is that once a jet stops being produced, there's just a few million years before the jet disappears, before the signatures of the jet disappear, so that we sort of understand the processes. This involves magnetic fields, as I mentioned, charged particles moving in magnetic fields. And these signatures can only last for so long. And so if you see two of them, we know that roughly a few million years at most has passed between their formation. And then we also notice that these active galaxies are found in more isolated environments. So there aren't many galaxies around the active galaxies that form these kinds of objects. And the lower right is actually data showing the so-called richness factor, which is that there are either many or fewer galaxies around these kinds of objects. And we noticed the green arrow there is pointing to the richness factor of these X-shaped radio galaxies. Notice that it's lower than the richness factor for the FR2s overall and for FR1s. So notice that FR1s seem to have the highest richness factor among these active galaxies, and this is something that we need to explain.